This is 5.7 double angle properties, and this is day 2. Okay, you need your formula sheet out, and remember double angles are on the back side. And what I would probably do with your notes today is I would try to do these on my own, and then I would go back and look at these and watch the notes since there's only three proofs. Okay, so the first one is sine of 2x, and this is a double angle property on the left side, and on the right side you have a fraction. So I think I'm going to start on the right side. So this is a 2 tan x over 1 plus tan squared. Now what people are not doing is telling me where you're starting, so make sure you write down the first thing that you're starting with. I'm always looking at where I need to end. Tan of 2x, and remember that's equal to 2 sine x times cosine x. Okay, this bottom one is a Pythagorean, so I'm going to replace that one on the bottom. So I'm going to go 2 tan x and try to replace that with a secant squared. And then how about we start replacing some of this mess. So 2 times, I know tangent is sine over cosine, so I can get my sine in there. And then secant squared, I'm going to pull out to the side. And I know I can change this secant squared. So this is 2 times sine x over cosine x. And I know secant squared is the same thing as saying cosine squared. Okay, at this point I know I can start reducing. I can take out a cosine. And it looks like I have my answer at this point. That gives me 2 sine x times a cosine x, and that is equivalent to my answer, which is a sine of 2x. Now this is not the only way you can do it. Remember, there's multiple ways. Okay, let's try another one. Let's see. I'm still going to start with this side over here. Looks to be a little bit more difficult. So again, write down the side that you're starting with so that I know where you're beginning. Okay, this secant squared right here, I'm going to pull out to the side, and I'm going to say that is 1 over cosine squared. Let's leave that on the bottom. This is going to be times 2 minus secant squared x. Let's see, I think I can replace this with some things right here. How about let's go ahead, how about we distribute that? Not replace, let's distribute. So that's going to be a 2 cosine squared minus cosine secant. That looks better. And the reason is because cosine times secant is going to give you a 1. Okay? Let's see what that does. Let me rewrite that. So that's going to be 1 over 2 cosine squared minus 1. Hopefully this reminds you of a double angle property that we've been working with. I'm going to replace that with cosine of 2x. And cosine of 2x is the same thing as saying secant of 2x. And we got where we needed to be. That was kind of tricky because we haven't used that a lot. Okay, let's look at the last one. I've actually worked this several different ways. I'm still going to start on the right side though. So writing down your first step, tangent of x times cosecant squared x over 2. Starting with my first step here. Okay, on this one, I'm going to start by replacing tangent. So that would be sine x over cosine x. I'm also going to replace my cosecant, so that would be 1 over sine squared. And this would be times 1 over 2. Let's see. I can simplify one of my sines. So I now have 1 over just rewriting, I have a 2, I have a sine, and I have a cosine. And I rewrote it because I know that 2 sine cosine is the same thing as saying 1 over sine of 2x, which is the same thing as saying cosecant of 2x. And again, if y'all saw that a different way, that's totally fine. Okay, bring questions to class.